Welcome back to the VR Creativity and Coding Camp. My name is Elena and I am one of your camp counselors here for camp. And what we are going to be doing now is completing the Maze Solver Challenge. So you've gone through and you've crashed castles with your VR robot, you've drawn using your VR robot, and now we're going to use our robot to solve a maze. To get started, the first thing we want to do is open a new project in VexCode VR. So we're going to go up to File and New Blocks Project, and then it's going to have us select the playground that we're going to use. For this challenge, we're going to be using the very last playground that's listed, which is the Wall Maze Playground. So we're going to select this, and it will open up our brand new project. And let's take a look at the maze. So we're going to open the playground. Now our maze here has a clear start, which is where we can see our VR robot. We can see the end of the maze, which is used with this checkerboard pattern, but there's also all sorts of different places for us to stop so we can have different challenges in our maze. We can see numbers and letters marked here in green and blue, and we have all different ways that we could solve our maze to either go to the very end or to go to these different stopping points. Now, so far, what we've done is use drivetrain commands to control the robot driving forward, turning, something with the pen going up and down. We've used those drivetrain commands to solve certain problems or to complete certain challenges. Now what we're going to do is use a different element of our robot in order to help us solve the maze. And what we're going to do is we're going to use a bumper sensor. So a sensor is something that our robot uses to gather data about its environment, about the space around it. The bumper sensors on our robot are located on the front. So let's go ahead and take a look at our robot. I'm just going to use a different camera view and swing it around to view the front of the robot here. And we have two bumper sensors on our VR robot. We have one here on the left when we look at it, and one here on the right on the front. There are other sensors on the VR robot that you'll be learning about later, but for right now, we're just focusing on the bumper sensor. The bumper sensor is a sensor that can detect physical contact. So it's used to inform the robot when it's made contact with an object, or in this case, a wall. Our bumper sensor will report when it is pressed or when it is not pressed, or you can also call that it's released. So our sensor can determine whether or not your robot has collided with a wall. So we can use that data, that sensing, and then have our code tell our robot what decisions to make based on the environment and what the robot senses. So it's going to sense something, it's going to think about that and make a decision, and then it's going to execute a behavior so it will act on it. So we call that the sense, think, act loop. And that's really what makes our VR robot a robot, is that it's able to sense, think, and then act as part of it. In order to use our sensor, our bumper sensor in the project, we're going to need to talk about some new blocks. So I'm going to go ahead and move my playground over to the side. I'm also going to just change that view so we can see the whole of our maze. There we go. Perfect. Now we have space for our code and we can still see our maze. The first block that you're going to drag into your project and follow along with me is our drive block, which is this very first block here. We're going to go ahead and connect that to the when started. And you'll notice that our drive block is a little different than the drive for block that we've been using before. So let me pull out both just so we can talk about them together. So if we compare the drive block with the drive for block, you're going to notice a few differences. The drive for block is very specific. It tells us exactly how far the robot should travel for that behavior. And this is what we call a waiting block. So this block, the drive for, will wait and complete their behavior before it moves on to the next block in the stack. So just like how you saw the green highlight previously, that green highlight will stay around the drive for block until it's completed driving forward that specific amount that you told it to. In comparison, let me go ahead and move that out. In comparison, the drive block is a non-waiting block. So it's going to continue to drive forward forever because we never told it when to stop. It's going to drive forward forever and move on immediately to the next block in the stack while it's driving forward. So this is really great when we're using it with sensors because we can continue to drive forward while waiting for our robot to gather some sort of data from our sensors. So in this case, we're going to be using the drive block with a block called wait until. So if we scroll down, we're going to scroll down to the orange control section. And we're going to drag in this wait until block. You'll notice it's shaped very similarly to our drive block, but there's this extra space on the inside of the block where we can actually put in another block inside of this one. So the wait until block is used with a Boolean condition. A Boolean condition is anything that reports true or false. So our bumper sensor in this case reports whether it is pressed, which is true, or it is not pressed, false. So our bumper sensor is reporting a Boolean condition because it reports true or false. And that's what we're going to use with our wait until block. So it will say drive forward and continue driving forward and wait until this condition is true. So the condition we're looking for is the bumper pressed? So drive forward until the bumper is pressed. If we scroll down into our sensing category, we'll see our bumper sensing here. And this block has a hexagonal shape. It has 6 sides to it, just like this shadowed space in this block. So I can tell that they're going to fit together because all of these blocks work like puzzle pieces. So I'm going to drag in this block and I can see that it highlights that shadow when I'm hovering over it, and it will snap inside of my wait until block. Because we have 2 bumper sensors, we can see that there is a parameter to choose between left bumper and right bumper. We're going to go ahead and stick with left bumper. We don't need to worry about using both because they're both on the front of the robot and both of them will collide with the wall. So now before we can test this, we need to tell our robot what behavior that we want it to do after the bumper is pressed, because otherwise my robot is still driving forward this whole time. So we're going to go back up to the very top to the drivetrain section. So you actually can click on drivetrain as well if you want to jump through categories. So I'm going to click on drivetrain. It will bring me right back up to the top, and I'm going to grab a stop driving block. So I'm going to drag that in and put it on the bottom. So now we have drive forward, and while you're driving forward, keep driving forward until the bumper sensor is pressed and reports as true. Then you can move on to the next block, which is stop driving. So it's telling our robot, you drive forward until the bumper switch is pressed. So we're going to go ahead and run this project. So it's going to drive forward, collide with that wall, and stop driving. So there's another really cool way to see if our bumper switch is being pressed or not. So if I move my playground back over, There's this button here on the top left, those 3 lines. If you select that, now we have an option to open our dashboard. So I'm going to open the dashboard. And here you can see information about all the sensors on the VR robot, the heading, the location. But what's really great is that you can see information about the bumper sensors. So you can see that the left bumper sensor is pressed and the right bumper sensor is being pressed because both are marked as true. When I reset the playground, it puts it back at the starting location, and I can see that both bumpers are reporting false. They're not being pressed. So now we're going to go ahead and start building onto our project using multiple wait untils in order to drive our robot to the letter A. So we're going to go ahead. I'm going to move this over to the side so I can still see my bumper. Perfect. So instead of stop driving when I reach the wall, I want my robot to turn so it can start going towards the letter A. So I want it to turn to the left. I'm going to go ahead and remove this stop driving block. And I'm going to drag in a turn for and change my parameter to left. So if I run my project again, it will drive forward until the bumper switch is pressed, turn to the left, and then face the next wall. So now we're facing this wall here, and we can repeat those same behaviors again. So we can go ahead and drag in these blocks all again, or there's this really cool feature in VEX Code VR. So I'm going to right-click on this drive forward, and I can actually duplicate blocks. So it'll duplicate everything beneath the block you clicked on. So I'm going to duplicate. It will duplicate all of these blocks, and then I can connect them all beneath here. So now if I reset and run my project again, forward, and turn. So now we're already almost at the letter A. Now let's think about what we did before our very first blocks. So we can duplicate these again. I'm just going to do this bottom stack. We're going to drive forward until this wall triggers our bumper sensor. And then we want our robot to stop driving. So I'm going to delete my turn left block, drag in a stop driving. And now I should be able to run my project and get to the letter A. So go ahead, you can watch this as it goes through. You can watch what the bumper sensor is reporting up here in the dashboard. And now we've made it to the letter A, which is amazing. So as we go through, we're going to be testing a lot of different solutions here on our wall maze playground. So if you want to go ahead and save your project, I'm going to save my project. We're going to go ahead and do drive to A as our name. I'm going to save this to my device. And now I have this so I can use it again if I want to build on my project later, or if I wanted to share this with somebody else. I'm going to close my downloads real quick so I have more space. And now we're going to reset, and we are going to talk about driving to the number 2 now. So we're doing some very similar actions, but we may need to change the project that we've written already. So let's go ahead. I'm going to change the name so I remember that I'm driving to the number 2. So if I follow my project right now, it's going to drive forward until this wall presses the bumper sensor, turn left, drive forward to this wall, turn left again, which is not what I want. So I'm going to change this left to right. So it's facing this way, drive forward and stop. So I should end up with my robot touching this wall right here. Let's test our project. In our wall maze project, we're going to have a lot of blocks as we add more and more to solve this maze. So it's really important that you stop and test your project regularly so you're not adding too many turns at once. So the next thing we need to do is we can remove our stop driving just like we did before. And we know that we want our robot from this point right here to turn left. Then we can go ahead and copy or duplicate. Once our robot turns left, we want it to go forward, stop when it hits this wall, and then turn left again. So I should be facing the two when I run this project. Again, we're going to be testing this really frequently just so we can make sure we're on the right track. And look at that, we're tracing the path of our robot, and now we can see what's happening and what direction it's going. This is a really cool place if you wanted to. You don't have to. You could put the pen of the robot down and actually draw the path of your robot as well on the playground. So now that we're here, we're going to drive forward until this wall and stop. So we're going to duplicate these blocks. I'm going to get rid of my turn and put my stop back in. So let's test this out. This should be driving to the number 2. Moving through. And we've done it. So look at how quickly now we're solving mazes, which is amazing. Now that we've driven to the number 2, we've met our goal. So I'm going to go ahead and save this project as well. So now I have all of these projects to show what I've done and all of the different accomplishments that I've made. I'm going to close that. Now we're going to try something a little different. We're going to try to drive to the letter B. Now you'll notice that there's not really a good place to get to the letter B. This hallway, if we draw the path our robot would need to go forward, left, right, left, left, and go down this hallway here in our maze. But there's no wall here to indicate when our robot needs to turn. So what we can do instead is use some of the other tools that we've done in previous videos and previous sessions. So now instead of here, when it hits this wall, turning to the left, let's go ahead and drive in reverse to go back to that spot. So I'm going to get rid of these blocks. So I'm going to add a drive reverse, and let's see where our robot ends up. So we can also follow this with the highlighting here on the robot. So it's driving reverse. It's not quite far enough, but this will allow us to reverse and turn so then we can face this corridor or hallway so we can go to the letter B. So let's change this to 300 millimeters instead. And then we can add a turn left block in just so we're right on the right path. So let's see if this turns us to the correct hallway. Perfect. So now we're on track to make it to the letter B. You can also check to make sure you've reversed far enough by checking your angles. So I can go into this chase camera and see that the robot is positioned quite nicely between these two walls. So I can go down this hallway here. You go back to top down. I always think top down is the easiest when you're trying to solve a maze, but you can use whatever camera view works best for you. Now that my robot is here, I can go ahead and use some of the same blocks as before. So I'm going to duplicate, scroll down. Now I don't need this reverse, so I'm going to get rid of it. So drive forward, and then we want to turn to the right. So make sure you're thinking about what direction your robot is facing. So what looks like it might be left to us is going to be to the right because of the direction of the robot, the orientation of the robot. Now we could go ahead and drive forward again. So we're right on track. We're going to duplicate this set of blocks. Drive forward again. Oh, make sure you reset each time. Now, one thing you could do if you wanted to is because we have these multiple iterations of drive forward, wait until, turn right, you could always use a repeat loop as well just like you learned about when you were drawing the house. But for right now, I'm just keeping all of my actions separate so I can keep track of them. But that's part of however you want to solve your challenge for coding. And lastly, we just need to drive forward to the letter B. So let's go ahead and duplicate this. We'll get rid of our turn right and we'll add a stop driving. So we'll stop on the letter B. So I'm going to go ahead and scroll up so we can follow our highlighting. Our robot's going to go forward, left, right, left, reverse, left, right, right, forward, and then stop driving once it's hit that final wall. So now we've driven to the letter B. So we can go ahead and save this. We've driven to B. We can save our project. And now we've solved 3 different ways or paths in this maze, which is amazing. We're going to do one more together before you go out and solve the whole maze by yourself. So we've done A and B, and we've done number 2. So now let's go ahead and add on to number 3. So let's go ahead and watch our robot again, figure out exactly where we need to change our project to drive to the number 3 instead of going to B. Now we can go ahead and go forward. We're going to follow our robot. And right here, if I stop, we're going to reverse, but then we want to turn right instead of left. So if we're going down that corridor. So I like to stop my project also, just so I can see exactly where it's happening. So reverse, and then we're going to turn right for 90 degrees. Then our robot will be facing upwards and we'll drive forward to this wall, which is this wait until. And then I believe we need to turn left. So let's go ahead and disconnect these blocks for a second so we can test things a little bit at a time. We'll reset and run this again. So we're going to do testing over and over, and that's the really great thing about VexCode VR is that we can test this project as many times as we want to. So now we've made it to this point. I'll go ahead and add these blocks back in. So next thing we want to do, we don't want stop driving. We want to drive forward and then turn to the right to face upwards this way. Let's add one more turn in while we're here. And then we're going to drive forward and turn to the left to face towards this wall. So let's go ahead and add this to the left. And we'll run and test it again. So our robot's going to follow that same path we started with for the number 2 and the letter B. And then it's going to diverge so we can get to the number 3 instead. So now we're ready. We can go ahead. We're going to need to drive forward, turn right, forward, right, and forward, right. So we're going to do forward and right 3 times. So let's go ahead and we'll do this. And let's go ahead and add in a repeat block. Since we know we need to do this 3 times, we can add it around these 3 blocks and repeat this 3 times and see if where that gets us. This is a really cool way where you can take some of the things that you've learned from before and also apply them in this kind of project when we're solving the maze. So now it's doing right once, right twice, and now right a 3rd time, and it's facing the number 3. So we can go ahead and grab these blocks that we stowed away and add on our drive forward just to make it right to the number 3. And we'll test this again just to show that we can make it all the way to the number 3. So this is a really cool way where you can use loops, you can use drivetrain commands, you can use the waiting and non-waiting blocks that we talked about, you can use the bumper sensor, all together in order to solve these different parts of the maze and these different paths. So now we've driven to the number 3. We're going to go ahead and save that project as well to your device. Now what's really great is you have 1, 2, 3, 4 different projects you can use as a base for going ahead and driving your robot from the starting location to the finish line. This has been such great practice coding your robot using the bumper sensor. So now you're going to take all of that practice that we've done together, and you are going to code your robot using the bumper sensor to drive from the start to that finish, that checkerboard finish on the playground. Make sure you're using things like the wait until block, the bumper pressing block, which is our Boolean, which reports true or false, as well as things like our drive block to tell our robot to drive forward indefinitely or forever until we tell it when to stop or when to do something different, like turn left or right. So you're going to use everything that we put together, and you're going to go ahead and solve our Maze Solver Challenge. Congratulations on solving the Maze Solver Challenge. You have now coded your robot to drive from the start to the finish using sensors and sensor feedback or data from your sensors to get your robot through the maze. Let's go ahead and take a look at my solution and what I did to get there. Now remember, this is just one example of a possible solution. Yours may look totally different, and that's okay. We all have different styles and creative ways to code in VEX Code VR. Now, I don't know about you, but my program is pretty long. So I'm going to go ahead and start this so you can see my robot running on the playground, and we'll follow the highlight to go through. So I used the drive to the number 2 example as my base, and then I added on a lot of blocks as we go through. The only really tricky part I wanted to mention is this right here, where you have to drive in reverse from the number 4 and move to get to that extra hallway so you can get to the end. That part I knew was a little tricky for me, and that might have been a spot where you had to use some of that same information like we did when we were driving to the letter B or the number 3, and use some of those same ideas that we did when we went there. But this is how you can code your robot to solve the maze.
Hello, my name is Lauren, another one of your camp counselors, and congratulations! You just went through with Elena and solved the maze using your VR robot and the bumper sensor. Now you may be wondering, Lauren, can I get through that maze without the robot touching anything? What if there's certain obstacles that I wanted to stop my robot before I collided into them? Can I do that? Is there a sensor that will allow me to do that? The answer is yes, the distance sensor. So what we're going to do is we're going to look through our maze again. We're going to go through and solve our maze a second time, but now we're going to do it using the distance sensor so that our robot doesn't have to touch any of the walls. So let's go ahead and look in VR and look in our playground to see how we can actually do that. So here's the project where we left off. Now I want to start a new project. So I'm going to come up here. If you have your maze solver solution from when you solve the maze with the bumper sensor, you can go ahead and save that before we move on. Now I am going to start a new project here. So I'm going to select new blocks project. We are going to scroll down and go back to the same playground, my wall maze playground that I was just in. And I'm going to have that playground load. And I want to take a look at some things here on my VR robot because we just looked at the bumper sensors and where they were on the VR robot. But as I just mentioned, how can I actually solve the maze without bumping into any of the walls? Well, I can do that using the distance sensor. So I'm going to move this over a little bit so I can see some of the different angles of my robot. And I'm going to turn this around so that I can see the front of my robot. And we already saw from earlier these two sensors right here on the left and right of the VR robot or our bumper sensors. Now our distance sensor is right here inside the eye sensor on the front of the robot. That's where our distance sensor is located. So right here in the front. Now what is the distance sensor? Well, the distance sensor reports the distance between the front of the sensor on the robot and the nearest object. Now, in our case, on this playground right here with our VR robot, it's going to detect the distance between the sensor and the walls of the maze. Now, how does this work? Well, the distance sensor is going to calculate the distance by using the time it takes for ultrasonic waves to bounce off of the object, in our case, the wall, and return back to the sensor. And then it can use that calculation to distinguish how far away the sensor is from the wall. So we are going to, again, solve a lot of the same pieces of this maze that we did with the bumper sensor, but now we are going to do it using our distance sensor. So that being said, let's put this back with my playground view so that I'm top down. And the first thing that we are going to do is we are going to try to drive to the letter A. Now, again, you already did this with the bumper sensor, so you may be familiar with how the robot needs to move and turn and drive. But now we are going to use the distance sensor in order to still drive to the letter A. But what exactly did you do last time? Well, you drove forward until the bumper sensor was engaged with this wall, then it turned. Then it drove forward again until the bumper sensor hit this wall, then you turned. And then you drove through the letter A until the bumper sensor touched this back wall, and then it stopped. So how can we replicate those movements without touching any of the walls? So let's go ahead and see what I'm going to have to start my project with. Very similar to what we did before. I'm going to drag in this drive block. I'm then going to scroll down to my control section. And I'm going to grab another wait until. But now, what I need to figure out and what I'm going to do is I need my robot to drive until that sensor is a certain distance away from the wall. And then I want my robot to perform some action, such as stopping or turning. Now we're going to come down here to our operators category. And we can see here there are 3 blocks, a greater than block, a less than block, and an equal to block. These are called comparison blocks. And what they do is they compare values. They are also Boolean reporter blocks that report a true value when the comparison condition is met and false when the condition is not met. So let's take a less than block. And because it is hexagonal in shape, we are going to put it inside our wait until block. Now, what we are trying to compare here is I want to drive forward and wait until my distance sensor is less than 50 units of measurement away from the wall. All right, now I need a block that's going to go inside this comparison block that will allow me to use the distance sensor. So we are going to go to the sensing category. I can see distance, and we're going to select this distance from block. Now, this distance from block is a numeric reporter block that's going to report the distance of the nearest object from the front of that sensor. Now, this is an oval block that's going to be used inside blocks with oval spaces. So I'm going to put that right inside that less than block. Let's go ahead and test and see what happens here. Oh, well, my robot continues to drive because I didn't tell it to do anything once that condition was met. So we are going to need another block that's now going to stop our robot from driving. So let's go ahead back up to the drivetrain section, drag in that stop driving block, and now let's test this. Can see my robot drive forward, and there we go. Once the condition, my front distance sensor, was less than 50 millimeters away from the wall, our robot stopped driving. Now, one other thing that I'd like to show you is that I know that you've already seen the dashboard for the bumper sensor, but it also is going to report the distance from the sensor to the nearest object. So if I reset this and run it again, you can see right now my distance is reporting 287 millimeters away from the wall. But as I run this, you can see, there we go, it's now reporting 17 millimeters away from the wall, which is less than 50. And that's why the condition was met and my robot stopped driving. So we do have that in the dashboard as well. Okay, now our robot did stop driving once the sensor was less than 50 millimeters away from the wall. However, I am not yet closer to the letter A. So what do I need to do next? Next, I need to turn my robot left instead of stopping driving once I am less than 50 millimeters away from the wall. So let's go ahead and remove the stop driving block, add in a turn for block, and I want to change that to left. Now when I try this, I'm going to reset this. When I try this again, my robot should stop driving once I am less than 50 millimeters away from the ball, but turn left instead of just stopping altogether. So let's go ahead and test that. And I turned. All right, great. Now I am facing closer to the letter A than I was before. But what do I need to do now? Well, I still need to drive towards this wall, stop, and then turn left again. So as I've already know how to do, I'm going to go ahead and duplicate this stack. And let's go ahead and try that again, because now I'm going to drive into the wall, turn left, drive into the wall, turn left, and that should allow me to now face the letter A. So let's go ahead and test that. Driving, turning left, driving, turning left. Great, I'm almost there. Now the next thing that I need to do is drive until I'm less than 50 millimeters away from the letter A. However, I don't want to turn anymore, I just want to stop driving. So I'm going to take this last section here and I'm going to duplicate it. But instead of turning left, I'm going to get rid of this block. I don't want to turn any further. I want to stop my robot from driving. So let's go ahead and drag in that stop driving block. I am going to reset my playground there. And I am now going to test this. All right, here we go. Driving, turning left, driving, turning left, driving and stopping. And congratulations, you did it. We now were able to use the distance sensor to drive to the letter A without touching absolutely any of the walls. Congratulations, you took all the information about the distance sensor that we just covered and you used it and we solved it together to drive to the letter A on our maze. Now, we're going to take all that stuff that we just learned about the different blocks that we use, the different comparison blocks, and we also used the distance from reporter block inside our wait until block. We're going to take all of that information and we're now going to drive to the letter 1. So let's go ahead and do that together. All right, so now that we actually could drive to the letter A here using the distance sensor, let's go ahead and name and save this project. I'm going to save this one distance to A because our last project with the bumper was drive to A. So this one's going to be distance to A so that I know that this one uses the distance sensor. And I am going to save this to my device. All right, now that I've done that, let's go ahead and reset and think about how I need to drive to get to the number 1 on the maze. Over here on the right side, I can see is 1. So what does my robot need to do first? I actually need to turn right. So I'm going to detach these blocks and set them down here because I'm going to use a lot of them here in a second. But the first thing that I need to do is turn right. So let's drag in a turn right block, a turn 4 block, and I need to turn for 90 degrees. Let's go ahead and test that. I am now starting in the correct orientation. What do I need to do next? I need to drive until I am 50 millimeters away from the wall, and then I need to turn left. So that's exactly what I have in this first part of the project that I used before. So let's go ahead and attach that. We're going to restart my playground here. My robot's going to go back to the starting position, and let's test what we have so far. Go ahead and drive forward, and now I am facing the correct direction. Okay, so how does the robot need to move now? Well, I need to drive forward and then turn right, which is similar to what I have here, but instead of left, we're going to need to turn right. So let's go ahead and change that. I'm going to reset the field here, and let's try again. So I'm turning, stopping at the wall and turning, and now I'm facing the correct direction. Now this last part here that I can see in my project, we're going to drive forward, but it's going to stop. So let's go ahead and test that. Going to continue facing, driving. But instead of stopping in front of the wall, I need to turn right. So let's go ahead and remove this stop driving block, and we're going to turn right for 90 degrees. Once I do that, I'm going to need to continue driving forward. So I'm going to duplicate this. And let's try what we have currently. So I'm going to reset this, turn right, drive into the wall, turn right again. And now we're facing the number 1. What do I need to do in order to finish driving to number 1? Well, I need to drive forward, but instead of turning, I'm going to duplicate this last part. Instead of turning, I want to stop the robot from driving because I don't need to turn any longer. I'll actually be on top of the number 1. So let's go ahead and reset one more time. And I'm going to go ahead and test this out. So turning, driving to the wall, less than 50 millimeters, continuing to turn, and there we go. Congratulations, you did it. We drove to the number 1. So now that I've completed this, let's rename, drive to 1, save, and I'm going to save this to my device. So now we have 2 different parts of the maze completed. We drove till we found the letter A, and we also just now drove to the number 1. Now, what's the next thing that we want to do? Next, I want to drive to letter B. So how can we actually do that? Instead of A and 1, now we're going to take that information and drive to B. All right, so let's go ahead and reset this, and let's see if I can use parts of my current project here in order to start to drive our robot to the letter B. Well, the first thing I need to do is drive forward until the distance sensor is less than 50 millimeters away, and then I need to turn left. So this first block right here, turn right, I don't need that because I want to drive forward. So I'm going to right click on that and I'm going to delete that block. So I'm going to break this up little by little here. So the first thing, I drive forward, wait until the distance sensor is less than 50 millimeters, then I want to turn left. Let's see if that's what I need my robot to do. So drive forward, turn left. Great, that's exactly what I wanted it to do. Now what do I need it to do? Well, I want to drive forward until I'm less than 50 millimeters away, then I need to turn right. So let's go ahead and take this from the project that I had before, drive forward, wait until my distance sensor is less than 50 millimeters away, and turn right. It's exactly what I just had. Let's go ahead and test that. Drive forward, turn left, turn right. Great. How do I need my robot to turn now? Well, I need to drive forward until I'm less than 50 millimeters away from this wall. Then I need to turn left. So let's take this next chunk of code here. I have these 3 blocks. Drive forward, wait until the distance is less than 50 millimeters, but I don't need it to turn right. I need it to turn left. So let's go ahead and try that. Forward, left, forward, right, forward, left. Great. Now what do I need my robot to do? Well, if I drive until I'm less than 50 millimeters away from this wall, what am I going to do next? Because I actually need my robot to stop here so that I can turn left. I don't want to go all the way to the wall. Well, that's okay because our distance sensor can detect more than just 50 millimeters away. So what I can actually do is if I pull up my dashboard here, we can actually stop our project in the current moment in time, and it will show me the current distance that my robot is or the sensor is away from the wall. So let's add these other 3 blocks. I'm going to drive forward, wait until my distance sensor is less than 50 millimeters away, and then we're going to turn right. But before we actually get that close to the wall, let's stop our robot right about here and see how far away we are. And then I can use that distance instead of the 50 millimeters. So again, this start button is going to turn into a stop button. So let's go ahead and use that. So let's go ahead and start our project. All right, let's go ahead and test this after a reset. Okay, turning left, turning right. And remember, I'm going to stop here. So I stopped my project. How far away am I? My distance sensor is 280 millimeters away from the wall. So let's go ahead and change this to 280 instead. And instead of turning right, I need to turn left. Now let's reset and try again. Driving forward, left, turning right, turning left. Look at that! I actually stopped before I got down further to the wall. Now, if I change my camera view here, I can see that I'm pretty close to that right side of the wall. So I might lessen that by just a little bit. So instead of 280, let's do 270. Just so that I'm not too close to the wall there. And let's test that again. Turning left, turning right, driving forward. Oh, it got me a little closer to the wall. So I don't want to go down. I need to go up. Let's do, instead of going down to 270, let's go up to 300. So let's test that again. All right, turning left, turning right, go, stopping. Okay, that's actually really good. I'm far enough away from the wall, and I'm going to continue to drive forward, which is what I have in this other section of blocks. Let's go ahead and test out everything that I have so far. Remember, we're trying to get to the letter B. Okay, turning, driving forward. Okay, but my robot stopped, and I don't need it to stop. I need it to turn left. So let's go ahead and change out this stop driving block. We're going to drag in a turn 4 block, and we're going to change that to left. And then once I'm facing this wall, what do I need to do? Well, I need to drive forward until I detect the wall and then turn right. So let's go ahead and duplicate this last section. But remember, instead of turning left, I need to turn right to face the letter B. So let's go ahead and reset my robot and try this again. Forward, left. Okay. All right. Oh no, I turned the wrong direction. But where did I turn the wrong direction here? When I drove down, I actually had my robot turning the incorrect way. Let's see that again. We can check in our highlights over here on this side. Keep going down, and I turned left, but I needed to turn right. So let's go ahead and change that to right and try again. Okay, how close are we to getting to the letter B? Very close. The only thing I have left to do is continue driving until I'm less than 50 millimeters away from the wall, and then I'm going to stop driving. So let's go ahead and duplicate this. We're almost there, but instead of turning at the very end, I need to stop. So let's get rid of that turn 4 block. I'm going to go to my drivetrain category, and I'm going to drag in that stop driving block. Okay, now it is important, as you can see, we do have a lot of blocks being added to our project. It's very, very important to test your projects in smaller increments. So as soon as I add a new behavior in my robot, whether I'm driving, turning, stopping, I want to test my project often because I don't want to build my entire project and then my robot move in an incorrect direction, and then it's hard for me to figure out where the problem exactly is later. So we want to be testing our projects frequently and seeing if we are on the right track to get where we need to go in this maze. Okay, we are driving to B. Let's go ahead and test it out. Driving, turning, stopping less than 50 millimeters. Okay, we're stopping a little early there so I can go down towards B. Turning right, almost there. And we did it! Congratulations! You now use the distance sensor to not touch any of the walls in the maze to actually drive to the letter B on this playground. So let's stop our project. I'm going to change this to distance to B, save that, and let's go ahead and save this to our device. We now have 3 different projects: driving to the letter A, driving to the number 1, and driving to the letter B that we used using the distance sensor. Congratulations, look at all the projects you're creating. We drove to the letter A, the number 1, the letter B, and now we are going to drive to one more spot on this maze together before you go ahead and solve the entire maze yourself from the beginning to the end where that checkerboard pattern is, just like you did with the bumper sensor, but you're going to complete that maze using the distance sensor. So let's go ahead and drive to the number 3 on this maze together, the last one we do together before you go ahead and solve the maze yourself using the distance sensor. All right, so let's go ahead and reset our robot here. Again, we're trying to get up here to the number 3. Let me detach what I have so far, and then we can use parts of it like we've been doing so far for this maze challenge. Okay, so how do I need to get to 3? Well, I still want to drive forward and turn left, because remember, I'm trying to get up in this direction. So I'm still going to drive forward until my sensor is less than 50 millimeters away from the wall. Then I'm going to turn left so I can take this little front 3 block here that I have, drive forward, wait until the distance is less than 50, and then turn left. So let's go ahead and test that. All right, what's next? I need to drive forward until I'm less than 50 millimeters away and then turn right, which is exactly what I have here. Drive forward, wait until distance is less than 50 millimeters, then turn right. Let's go ahead and reset and try that. Left and right. Okay, now what do I need to do? Now I need to drive forward and turn left once I am 50 millimeters away from this wall. So drive forward, wait until distance is less than 50, then turn left. Let's reset and try that. Forward, left, forward. Okay, now I'm facing the right direction, but what do I need to do now? Remember, when we drove to the letter B, I stopped here and then turned left, but now I need to stop here and turn right. So I can use this that I had from my earlier project where I drive forward, wait until I'm less than 300 millimeters, which was right here, away from the wall. So I'm actually stopping further away from that so I don't get too close down to the number 2. But instead of turning left, I need to turn right. So let's go ahead and change that. And let's test what we have so far. I should be orienting and facing this direction so I can go up here towards the number 3. So let's reset and play that. Okay, forward, left, forward. Okay, now I need to turn right. All right, I'm facing the correct direction. I need to drive forward until I'm 50 millimeters away from the wall and then turn left because remember, I'm trying to get up here. I can use this portion that I have right now in my 3 blocks right here. Forward, wait until the distance is less than 50, but I need to turn left instead of right. I'm going to move some of these blocks up a little bit so we can see them. Let's go ahead and reset this. Try it. Drive forward, left, drive forward. Okay. All right, I'm facing the correct direction. Okay, we're getting so close. All I need to do is drive forward, then what? Turn right to face this direction. Okay, well, I have that right here. Drive forward, wait until the distance is less than 50 millimeters, then turn right. Let's connect that. Reset my robot. Oh boy, I'm getting so close to the number 3. Drive forward, turn left, drive forward, turn right. Okay. Oh, we're almost there. Oh, okay, what do I have to do next? I have to drive forward until I am 50 millimeters away from this wall, and then I need to turn left, because remember, I'm trying to get up here and around to the number 3. So I need to drive forward, but instead of stopping, remember, I need to turn left. So let's get rid of that stop block and add in a turn floor, but I need to turn left. I'm going to move this up just a little bit. Let's go ahead and reset and try that. Drive forward, turn left. Okay, where are we now? All right, almost there. Now let's see what else I have to do. I have to drive forward and then turn right. So let's go ahead and duplicate this. Remember, instead of left, I need to turn right. Once I do that, I need to drive forward until I hit this wall and then turn right again. So let's go ahead and duplicate that one more time. But let's think about this because I have a right and then a right. So if I drive forward, turn right, drive forward, turn right, drive forward. How many times am I doing that? Let's see. 1, 2, 3. 3 times? Well, let's go ahead and remove this one and let's see if I can add a repeat block here because I'm doing those actions 3 times. Now let's see where that takes us. Let's go ahead there. Okay. I'm going to turn right. And remember, we're going to get down here and repeat that right behavior 3 times. 1, 2, 3. Okay, what do I have left to do? I have to drive forward until I'm less than 50 millimeters away and then stop driving. So let's add in our last portion. I don't need to turn right there. I want to actually stop driving. All right, here we go. Let's reset it. Can we get to the number 3? Let's see. Let's go, VR robot. You're almost there. Turn right, turn left. Building our project. Okay, here we go. Let's see. I'm going to turn right 3 times, drive forward and stop. And congratulations, you did it. You drove to the number 3 using the distance sensor and not touching any of the walls in order for you to get there. So let's go ahead and change this to distance to 3. Save that. And let's save that to my device. Okay, so now I have 4 different projects that I have now used the distance sensor to get to. We drove to the letter A, we drove to the number 1, we drove to the letter B, and we drove to the number 3. Now what you're going to do is you are going to create a project. You can use any of these projects that we did together as a start. Whether you want to do the drive to A, 1, B, or 3, if you want to open some of those projects and use them. Remember, if you forget how to do that, you can do File, Load from your device, and then pick the project that you would like to build on or change. And you are going to drive your robot from the start location all the way to the finish, which is that checkered position there at the end. Now, you can use the project that you've done previously with the bumper sensor, and you can change some of those bumper sensor blocks that you were using before and use the distance sensor instead. You can start completely from scratch. Any way that you want to solve this challenge is completely up to you. So what you're going to do is you're going to pause the video. You're going to go ahead and you are going to create that project. Remember, when you're done with this challenge, solving the maze using the distance sensor, remember that you are going to save that project. Now, your previous project was Maze Solver. Maybe call this one Distance Solver or Distance Maze, just so you have different names between the 2 projects that you're going to create. So go ahead and create a project and go ahead and solve that maze using the distance sensor. And when you're done, come on back to this video and we're going to look at a potential solution. All right, congratulations. You solved the maze using the distance sensor this time. So let's go ahead and look at one of my potential solutions. I named this Distance Solver and I saved this to my device already. Now, again, there are many, many ways for you to actually solve this maze, but I'm just going to go over my solution so that you can see what it looks like. My solution is very similar to the one that I used for the bumper sensor, except mine's now using distance. So I'm going to have my robot start at the beginning and let's go ahead and watch it go throughout the maze. Now you can see I'm going to go ahead and I do have a lot of blocks in my project, so I'm going to move this down as it's going. Getting closer to the end. You can see here once I make this next to last turn, I'm going to have to stop a little bit early. I have 300 millimeters there. That was a little bit tricky for me. Turning left. Oh, almost there, VR robot, and done. Made it. As you can see, that is my example. So congratulations, you did it. I hope that you had just as much fun as I did. I know that saving this, going through and solving this maze using the distance sensor, not touching any of the walls instead of using the bumper sensor was really, really fun for me. Now you may be wondering, Lauren, we learned about the bumper sensor and we also learned about the distance sensor. And yes, you can solve the maze using either and both of those sensors. So what's the difference between the 2 sensors? When would I use one over another? Great question. Let's take a look at some of the advantages of both of the sensors in different situations. So just to recap everything that we had in this session, we looked at the bumper sensor, we also looked at the distance sensor, and yes, you can solve the maze using both of these sensors. However, the bumper sensor is obviously used when the sensor is touching an object, it reports pressed or released, and there are 2 of them on our VR robot. Our distance sensor is very similar in the way of using the bumper sensor where we can use it to solve the maze. However, it's going to be used when we don't want to actually touch any of those objects. So if we're trying to avoid objects and things of that nature, we can use the distance sensor. Okay, so we can also, what's nice about the distance sensor is change the distance. So we saw those comparison blocks. In some of our examples, we stopped 50 millimeters away from a wall, and other ones we stopped further away, like 300 millimeters away from the wall. So as you can see there, both of these sensors have their advantages, and we can use them both to solve the maze. All right, I hope all of that was really fun and helpful, and we'll see you in another session of VR Creativity and Coding Camp.